All right, in this lesson right here, what we're going to be doing is taking a look at pointers. Man, pointers play such a critical role in programming. Wouldn't you say, Joel?
Oh, definitely.
I mean, any program that you open up, you're going to see the use of pointers all over the place.
Plus, they're just plain cool.
They are cool.
Yeah.
So anyways, while the picture may be a little bit fuzzy at first, I mean, it's a simple concept.
Yeah.
But it's easily confused. And what's going to happen is, as we progress through this VTM, we're going to start introducing some other concepts that are going to continue to reinforce pointers and make the picture clearer and clearer. Does that sound pretty fair?
Yeah.
That sounds very fair.
Okay. So this lesson here is really just a foundation for pointers, if you will.
That's right.
So with that, Joel, take it away.
All right. So the first thing is basically, what is a pointer? Dan.
A pointer is a variable
No, keep on.
that references a memory address of another variable.
Okay.
Okay?
So
Yeah.
the data that it's holding is really an address.
That's right.
For some other place
Exactly.
where there's data stored elsewhere.
Precisely.
All right.
Oh, yeah.
I'm just making sure you're awake, Joel.
Yeah, I think I'm awake.
Okay.
Okay.
Let's see.
So the first thing, why don't we go ahead and create, well, this is just a simple program that I've set up, very, very, just like we did in the
Standard.
first VTM, right, very standard. Let's first create a simple character. Let's just call this C, and let's put inside of it the character A. Now, you all know what this is. The variable C is holding the value A, right?
Yes.
And what we can do is have a character pointer point at the address of the variable C.
So how would I write that?
You can do this. This is very cool. Character, and then to differentiate this variable as a pointer, put a little star in front of it, and we can call it PTR, just meaning pointer. So we now know that this variable right here is going to be a pointer. In other words, it's going to hold an address.
It's going to point to a character variable.
Yes, it's going to be pointing to a character variable. Now, the question is, how do we get the address of this variable C? If we just put C here, it would put the value of A in there.
And that's not what we're looking for.
Not what
because
we're
that's
looking for
not
at
a
all.
pointer.
That's an address to somewhere else.
Yeah, we'd have no idea where that's going.
Exactly.
So what we need to change this to is put an ampersand in front of it, which is what operator, Dan?
It's the dereferencing operator.
Ah, very nice. So that's going to give us the address of C. So we can end that with a semicolon, and if we just compile this, look at that. Everything succeeded, no failures.
But now, as the student, I've got to remember to play the student role here. Okay, now you've got a variable that's like pointing to an address.
Yeah.
Why would you even want to do that?
Well, what's really convenient about this is, well, like I said, it becomes very important when you're dealing with like functions or classes or something like that. So we'll be discussing that in the
Which is
future.
part of the whole picture becomes more clear throughout the night.
That's right.
Give it your best shot. Why?
Why? All right, well, let's see. The best reason is so that you could have, let's say you have another variable that holds the address, and PTR, no matter what C changes to, PTR is still pointing at this value.
Right.
So you can still change it no matter how much C changes. The value of C changes.
Okay.
But it becomes very, very important when you have, say, arrays. You can have a pointer point at the first element of the array, and you can step through that.
Right.
So that becomes really, really important. But this will become more clear. If that just didn't make any sense at all, don't panic, don't fright, just sit tight.
Don't fright? Okay, I'll try not to fright. Okay.
Oh, that scared me. All right, so let's print out these two values, these two address values, so that we can see what's in it. So let's see out the address of C, and let's just put an endl. So that should give us the address of C. Now, if we see out the value of PTR, what should we get, Dan?
Well, we should get the memory address of where C is located.
So we should be printing two identical values.
We should be, but I have to warn you before you compile this.
I think I know what you're going to say.
Yeah, we had to do some typecasting. This
Right.
is something that, don't freak out. Basically, what we want to have happen is we want the compiler to treat it as an integer.
Right.
Because right now it'll treat it as a character, and we're going to get some garbly gook
Yeah,
on the
why don't we
screen.
just compile
Garbly
this?
gook. I like
just,
that.
Just look at that. Let's just look at that. That's
Yeah,
Garbly gook.
man,
garbly gook.
yeah.
And we can't really understand that. So we'll just typecast this over to an integer, so it's a number that we can understand. And let's just run this quick and check that out. The address of both of them is 12.44.887. So they're both addressing the same memory location.
Well, yeah.
Well, yeah.
Yeah.
So here's the thing. Why don't we show one more thing, and then we'll switch over to Photoshop and kind of give you a visual representation of what we're doing.
Yeah, we're going to go old school with some whiteboard action going
Yeah,
on.
and if you don't like the way it's drawn, it's not my fault because I'm not the one controlling the
Yeah,
pen.
that's going to be me.
Yeah, haha, I'm going to laugh at you. Anyway, if we want to change the value of C. There's two ways we can do it. We could, well, there's actually a lot of ways, but we could say C equals, let's change this to B. All right?
Okay, I agree with that.
Now, what if I wanted to use the pointer PTR and change the value of C? Well, I can do this by putting in a star, which is, what operator is this called, Dan?
That would be the reference operator?
Oh, yeah, that's the reference operator.
Yeah.
So if we say reference PTR, now we're dealing with the value that
What's
PTR
in
points
that
to.
address.
Right. So if we say star PTR equals D, what's going to happen when I say C out C? Somebody. Oh, no, Buzz, since you're the student.
You're going to get X.
No.
I'm hoping that you see D.
Yeah, so if we say
Because you put in B, but then you turned right around and you said, at that address, put
At
in
that
D.
same address.
That's right, which is the same address.
Yep.
Put in D. So you just overwrote the B that you put in there.
exactly. So if I run this, look at that. It prints out the value D. Does that make sense, Dan?
It makes sense to me, but I've been programming for a while.
Okay.
Yeah, to a beginner like me, this is confusing.
This is confusing you?
I'm trying, but I think the whiteboard example is going to really help.
Okay, so let's switch over into Photoshop. Ooh.
Photoshop.
Ooh.
All right,
Wow.
Dan, you can take over now.
Okay, I'm going to take over.
Pretty boxes.
Pretty boxes. This is what we're going to abstract to be memory inside the computer.
Can I laugh at you now?
No, thank you. Oh, Buzz did. He's going to throw some paper at me pretty soon, being a student and all. Memory, boxes, containers. Inside these containers, we store our variables' values.
Right. So
And-
memory is like a continuous set of boxes.
That's right, just one after the other. And they each have an address. In this case, I'm just going to scribble down some
And of
values.
course, depending on where you are in memory,
These
these
will
values
change.
are going to
These
be
will change,
different.
but they're always going to be sequential.
Right.
That's important. So in our example before, we declared a character, and we called it C, did we not?
Yep.
And we made it equal to the value of A, right?
Yep.
Well, when the computer gets hold of this, it'll say, okay, I'm going to have a variable C, and inside of memory, I'm going to store A.
So that variable C now has address 004.
That's right. And then when we do a pointer, so we say char PTR, and I'm just going to say this for now and then jump back down to it again.
Since PTR is a variable.
It is a variable.
It
In
is a
of
variable,
itself.
so it's going to be stored at a memory address.
Right. And currently it doesn't have
And
anything
currently
in it.
doesn't have anything. So when we say equals C,
Ampersand C.
oh, ampersand C. Oh, my bad. Like I said, I've been programming for a while.
Oh, yeah.
What we wind up storing inside of memory is actually 004.
That
Because
makes sense.
This right here is actually going to put in that memory address right there.
Right. So that's actually looking pretty good. So basically, PTR is going to be pointing at that memory location.
That's right.
Very, very cool.
And then when we went in there and we started changing some values, like we set C equal to B, we came in here and we changed this value right here to B.
Oh, very, very cool.
And then when we started changing the pointer, when we started saying star PTR equals, what do you change it to? D?
D, yeah.
D?
Yep.
D. Since this guy is still pointing to this memory address, just the pointer itself,
Right.
what the D reference says is, I'm going to start working with this data.
Right.
So we go up here and we erase it, and we're going to change it to D.
Does that make more sense to you, Buzz?
That's really helping. So as a beginner, I know how you can also add things to variables, which we
Right.
talked about in the last VTM. So if you didn't happen to have the star at the beginning, if you just said PTR
Right.
equals, you're actually populating it then with a new address.
Right.
That's something very important to keep in mind. That's also a pretty common mistake for beginners.
That's right. Let me switch back over into .NET here for a second.
Oh, Dan was having so much fun.
Yeah,
Too bad.
I didn't get to draw any cartoon characters.
And it was coming.
It was.
Deal with it.
Okay.
All right, so if we said something like PTR equals D, this is very, very wrong. And if I tried to compile this, we get an error, cannot convert char to char pointer. That's a bad thing. That's
Yes.
something that cannot be and should not be done. So avoid that. Now, another thing. You can still manipulate pointers. Well, let me try to get my mind straight here. It would be best. Let me first give an example. How's that sound?
I like the root of examples because
So-
they're very visual.
Yeah,
And
they
you
are.
can talk about them.
At the same
At the same time.
Oh, special.
It's brilliant.
It's brilliant. Now, as I said before, we have arrays that are very, very important. That's where pointers actually become important. So let's declare an array, just like we did in the first VTM, if I'm not mistaken.
Yeah.
We did.
You did. In the last section of it, you talked about arrays.
So let's declare a simple array, and check that out. Isn't that awesome? My array has 4 elements, 0, 1, 2, and 3.
Now, right there, if you guys don't mind, I'm going to get you guys to work together for a second.
Uh-oh.
Said I wasn't going to talk.
Oh, boy.
Dan, put that in your mind real quick, because I'm going to have him jump you back over to Photoshop real quick. And he was nice enough to set up 4 elements there. Let's go ahead and put the 4 things in. So let's reproduce that with a 0, a 1, 2, and a 3.
Okay, wait. Oh, did I memorize it well enough?
I know it's pretty tough.
It is pretty tough. Let me just scribble, erase.
You're actually erasing.
Coolest eraser.
That's so cool.
That is really neat. Okay, so again, we have our memory addresses, right?
Uh-oh.
Which
Here
I
goes
was
him
so
with the
nice
memory
to.
addresses.
Don't mind the handwriting. I'm kind of rushed at the moment. So let's say, right here, 1.
Actually, it was 0.
Oh, 0. Oh, my memory. 0, 1, 2, 3. And we called this thing
my array.
My array.
Now, here's something that becomes really, really important. That first element is index 0. That first element is index 0.
Yes.
But what does the variable my array hold if I just directly call it?
Well, if I think about it for a second,
1.
my array.
He could spell, really.
Yeah, actually, we were having problems with that earlier today.
Yes, we were.
Yeah, is actually going to point at that memory address right there.
Right. So
001, that is.
Yeah, 001. So my array actually is holding the value 001. So let me switch back over. So, yeah, all right. So we're back over to here. If I print out my array, let me see out this, and now it should be understood that when we say my array, that is a pointer. If you say my array, I can spell too, my array index 0, that's actually getting the value at index 0, which is going to be, 0. Actually, you know what? Can we just bump this up one?
Sure.
Because that kind of
it can be confusing with the index being 0 too.
So index 0 is going to have the value 1 there. Now, my array is a pointer pointing at value 1. It's not actually the value, it's an address. So if I just print this out here, let me just compile this and run it. Ding ding ding. It's printing the address 1244872.
Which is very different than 1.
Yeah, very.
Very, very different
Very
than
different.
1. And another way you could do this, well, let's do this. See out. Now, my array index 0. We all know that this is going to give us 1, right? And just to prove that, just in case someone doesn't believe me, look at that. And it's going to give us 1. Now, what if we added an ampersand in the front? What's that going to do to us?
Well, an ampersand is a dereferencing operator.
So it's going to get the address, right?
It should give me the address.
So it should give the address of the first index. Index 0.
Index 0.
So these two numbers should be the same. Look at that.
Oh. But what happened?
This is going to give... This printed it out in a hex. So don't freak out. Don't scream or do anything crazy. Let me just do this really quick. And what this will do is now you'll notice that both of the numbers are absolutely identical. Just a second ago, all it was is it converted that number over into hex. The two numbers are really identical because that's the important thing to realize. So let's just switch back over into Photoshop for a second. And you'll notice that right here, index 0 is address 001. Index 1 is 002. Now if we switch back over into here for a second, hope I'm not totally confusing anyone yet. If I change this over into 1, look at this. You'll notice that the first one is pointing at index what?
1244872.
Right. Well, it's index 0 of the array.
Oh, my bad.
Yeah, that's what I meant to say. That's what you meant to say, right?
Yeah, I meant to say that.
Yeah, of
course.
course.
That's what I heard him say.
Yeah, I did too. The second one is going to be 1244876. You'll notice that's exactly 4 greater, right?
Which is the bit size of an integer.
The byte size.
Byte size of an integer.
That's what you meant as well.
Well, I tend to work in units.
Yes, you
So
do.
an integer is a unit of memory.
Right.
I don't tend to work at the smaller level.
Yeah, that's fine.
That's okay.
I can live with that. So it's 4 greater. Now this is where pointer arithmetic and that sort of stuff comes in kind of handy. Now what if we wanted to loop through this array just like we did before? Well, we can do this very simply with our wonderful for statement, for loop. Oh yeah. So let's say int I equals 0, I is less than 4, If you guys don't know how to do this,
Go back to Module 1.
that's right. So we could say int val. So we've just created an integer val. We're going to say this is equal to, if we said my array. What's that going to do for us?
Are you asking Buzz the student or Dan the not-so-student?
I'm going to ask you, Dan, the not-so-student.
Dan the not-so-student will say that what we're going to do is we're referencing our array pointer.
Right.
We
So
can say.
it should print out the first element every single time.
It should, which would be the value 1.
Right. Let's just get rid of these two couts for just a second, and let's run this.
Which you're not going to see anything at the
Well,
moment.
you're not going to say anything because I forgot to put a cout statement. I knew that. I really did.
It's okay, Joel. We know you like the debugger.
Yeah. So you'll notice that it prints out 1111.
Which is fine because it was a for loop and it's going to print it 4 times.
Exactly.
Yeah, so that's not a problem.
So that is a good thing. Now what I want to do is let's create an integer pointer. Remember last time we created a character pointer? This time we'll create an integer pointer. So int pointer, and we'll call it PTR just like we did last time.
That sounds good. It's just good to remember that when you're dealing with pointers, you need to match them up.
That's right.
So if you are dealing with integers, use an integer pointer.
Right.
If you're going to be using characters, then
Use a character pointer. Right, exactly. So we're going to assign this. Now, what is the address of the first element? I want one way from you and one way from Buzz. So you tell me the first way.
My array?
My array. Buzz. What's the other one?
The little ampersand thingy.
So what we could say is PTR equals
Referencing operator.
my array, but we have to pass it index 0.
Right.
So either way is fine. We'll just comment this line out and just use the top method.
Yeah.
So now what we want to do is loop through this array, but only using this pointer, this one pointer.
Sounds
and
good.
this is where we're going to start using pointer arithmetic, as it's so wonderfully called for some strange reason. It makes sense. We can come in here and say star pointer. That, for the first loop, is going to give us what? The first element.
It's going to give us the first element because we are referencing the pointer.
Exactly.
Which is we're going to look up what value is stored at a memory address.
Right.
Which in this case is 1.
Exactly. Now, if we want to move to the next element in this array, what do? PTR plus plus. So that just advances the pointer one step. Does that make sense?
In my terminology, I would say it advances the pointer 1 unit, which is, in this case, the amount of memory it would take to get to the next integer value.
That's right. And that's why it's important to make sure when you declare your pointers, you use integer pointer.
They're of the right type.
They're of the right type. Otherwise, you could screw a lot of stuff up. We don't want to do that. So if we just run this quick, check this out. Bang, bang, bang. 1, 2, 3, 4.
That's very nice.
It is very nice. And just because I'm a freak about this kind of thing, I'm going to print out the value of PTR. Now, what is the value of PTR?
It's going to
be an address.
Be an address.
Yeah.
Exactly. And this is going to be incrementing in steps of what?
4.
Yeah, oh, exactly. Can't believe I have to give you guys hand signals. That's sad. Anyway.
That was a hand signal? That was sad.
Okay, very funny. And you'll notice that, okay, this may be confusing again. So let me just exit out of that.
Well, you see, Joel is a native hex person. He walks around the office all day and he's like, 0xFF. And we just all laugh.
Did you say X?
Yeah.
Oh, okay, yeah.
Yeah, because it's hex.
Yeah.
Yeah, I'm,
Yeah.
You
it's
were
my
nice
own
enough to put
pathetic
the X in
attempt.
there, yeah.
For hex, yeah.
Aren't
Like
you nice?
FFABC 00FFA. Ooh, Joel, don't talk to me like that.
It's scary. So let's say Control F5, and you'll notice that it starts out at 7.2, bumps up by 4, increments by 4, increments by 4. So the pointer arithmetic is going to automatically handle that just for us. Isn't that nice?
Very nice.
So, does that make it clear to you, Buzz, since you're the student, the dumb student?
Yes, it does. I see that if we look at the picture again back in Photoshop.
Okay.
Basically what's happening is we're starting out by pointing at that very first memory address.
Right here.
And then we just simply look at the next one. And then we look at the next one. And we look at the next one by incrementing the value that's being stored in PTR. And that value happens to be a memory address.
That's right.
That's right.
But as far as anything's concerned, I mean, it's just a number.
Yep.
That's stored in PTR.
Yep.
Just happens to be an address.
Exactly.
Sweet.
Oh, it's so cool. I'm excited. Not really. All right.
Calm down, big boy.
I'm trying. All right, so now let's do another example. Since we've already kind of covered pointer arithmetic, I think the next thing that's really, really important when dealing with, well, pointers is dynamic memory.
Yeah, you're going to find that dynamic memory is one of those features of a programming language that you will grow to love because you don't always know how many elements you're going to have, say, in an array.
That's right.
And you're going to have to figure that out at runtime.
Exactly.
That's right. I knew there was no way you were going to say it twice.
Yeah, if it's... whatever.
I say exactly.
Yeah, no, that's me.
Exactly.
Oh. So inside of here, let's do a simple memory allocation thingy. So first, when you want to allocate memory, the first thing is it's only going to return to you an address. So you don't need to, like we did before, say like my array, and then say bracket bracket with 5 inside of it.
Yeah, which in this case we're going to want to have 5 units of memory given to us.
That's right.
Yes.
In this case, we just need to create a pointer. And a pointer initially, actually, let me just call this PTR. This is going to not hold anything, any specific address that we know.
I'm going to call it Garblegook again.
All right, call it Garblegook if you want to. And right now we don't know what it's pointing at. So what we want to do is make this PTR point at something useful. And we can do this via the new command. We can say new int, and then we can even give it a bracket and say 5. This does exactly the same as our myArray if it held 5 elements.
That's right. The new command is basically asking the computer to give me some amount of memory.
Right.
And that amount of memory that we want is of an integer type.
Right.
And we want 5 units of it.
That's right.
And so
it finds that.
It finds it for you, and it gives us the pointer, the addresser of the first start, the start of that memory block.
And it now allocates it to us. I mean, that's now ours.
Yeah,
this
that's
is
right.
in use. And we may not have put something in it.
Right, but it's ours.
It's ours. That becomes important to remember later.
Definitely. And, of course, we could, if we wanted to, just have one integer, just get rid of the brackets. So,
but then again, why bother doing that?
Exactly. There's no real point, but I thought it was cool to say.
It's a nice example.
I traveled all the way around the world to check my mail out front.
Exactly. So let's change this over to 5. And now we can say PTR. This is, of course, pointing at the first element at the moment.
Yep, that is.
And we can say PTR equals 5. Ooh, isn't that special? Now, what would we do if we wanted to point to the next element? Somebody tell me.
I prefer array indexing.
All right, so Dan would say PTR 1 equals 10. So now the second element is going to equal 10.
That's right.
Now, because I'm a guy that likes the other way, which is pointer arithmetic, I'm going to say PTR plus equals 2. So now what index am I looking at?
You will be looking at the third index.
Yes, I'll be looking at the third index.
2 index?
No, 0, 1, 2, third one.
Yes, that's right. Buzz is right.
Yeah, Buzz, good job.
Hey. Woo! Student got one right.
All right.
I've met my quota for the night.
Oh, that's cool. Now let's at the very end here just do a simple for loop that loops through our 5-element array to print everything out. So let's say int I equals 0, I is less than 5, I plus plus, and stuff, and cout, PTR, and I'll use... But here's the thing. I want to drive this home. This is important. So before any of you freak out, just bear with me. All right, there.
Joel, I don't want you to freak out or anything.
What is this going to do?
Well,
it's not going to work, is it?
We did some interesting things with pointer arithmetic here.
So what's going to happen?
Well, we're going to be... Our pointer, our PTR, is actually going to be starting at the memory... Index 3. The memory address of index 3.
So how do we fix this?
We're going to have to minus equals 2.
We can either minus equal, or we can do something else. That's just create another pointer that points to the same address.
At this point, representing all of the students out there, they're probably thinking, huh?
Okay.
Minus equal to what? Who?
All right. Here's the thing.
Okay.
Let me put a breakpoint because I'm a debugger guy.
Yeah.
All right.
I like that though. I really do like that.
All right. So let's just jump into this guy. And right here, right now, PTR, you'll notice the value inside, which is the address that we're supposed to be looking at, holds C. C. So that's nothing that we want. But check this out. After we run line 9, dink, it just gave us a correct address, which has, 5 elements in it. If we do this, of course, we don't have anything at the first element, so it's not going to show us anything. So right at this point, we can say star PTR equals 5. So we're changing the first index to have something. Now, just because I'm the kind of guy that likes looking at stuff, we're going to go into the watch window here and say PTR 0. So this is the first index of PTR. If we press F10, it's going to fill this value with the value 5. Dink.
That's very nice.
That's very nice, right? Now we can come in here and say PTR 1. So this is the second element or first index.
That's right.
Dink, that doesn't hold anything. So PTR1 equals 10. Bink, that's perfect. Now, when we say PTR plus equals 2, let's put in the value of PTR. And if we open this up, this is the first element that it's looking at, 5.
But its address...
The address is 321400. When we say PTR plus equals 2, it's going to add 8 to this number.
You are actually changing PTR at that point.
You're changing PTR. So check this out. Dink, look at that. It just made 0 and 1 almost like it's not right or something, right? Well, what it really did was it changed the value or address inside of PTR. So you'll notice now this value is 321408. It used to be 321400. So that's a bad thing. Well, it's not really bad.
We just have to be aware of it.
We just have to be aware of this fact. Because now PTR isn't pointing at the first element anymore.
Right.
And that's kind of a problem. So if we say PTR equals 15, that in effect changed the third element. But right now it looks as if it's changed index 0.
Okay.
So what we need to do to get back to the first one is minus off 2, right?
Yes, which will take us back 8
exactly.
in our memory address.
So PTR minus equal 8.
8?
Oh, my bad. I meant 2. You got me all confused.
This is when integer units come into play, everybody.
Very, very funny.
Yeah, I know. I'll be quiet now.
You can, dude. All right, so we're in here. Remember, we've changed it. It goes to 5, then 10, then we add, then change the third element to 15. Now what we need to do is move PTR back 2 units, which means 8 bytes.
Before you do this, though,
Yeah.
could you put it in the watch PTR 2?
Sure.
I just want that to be there so that people out there in VTM land can see that value is going to change.
Yeah,
Right.
that's a good idea.
So right in here, we can say, dink, and look at this. Index 0 has now become 5, index 1, 10, and index 2, 15.
And our PTR address is back to where it started originally, when we declared a memory.
That's right. So everything is perfect for us doing
To
this
start
loop.
in this for loop.
That's right. But you'll notice that PTR index 3, which is our fourth element, is undefined, and the fourth one is undefined as well, but that's okay for our purposes. So let's just run through this. Let's just press F5, or Control F5. So 5 is the first element, 10, 15.
And then
perfect.
gobbledygook.
And then gobbledygook.
Because that was undefined.
That's right.
It's just we have that.
Whatever's sitting
but
out
it's
there.
not, yeah.
Now, that should make it pretty clear. Are you fairly clear on that?
Yeah, I think so.
Do you think you
No,
just may need to rewatch the VTM a few thousand times?
Sure, I'll go with that.
Okay.
Yeah, that works.
So, there's one problem, though. We haven't deallocated our memory, if you will. So when we take memory from the computer, we always need to give it back. It's
That's
not
right.
nice if we don't.
I like to think of it as a warehouse full of boxes.
All right.
A computer only has so much memory.
Mm-hmm.
And in a warehouse, say, we only have so many boxes. So as we keep taking boxes out of the warehouse, if we never put boxes back, the warehouse gets empty.
Right, and then we have no boxes.
And we have no
to take.
boxes that we can take.
Right.
So we need to put them back when we don't need
When
the
we don't
boxes
need them anymore. Because like Buzz was saying, after we say new, we have taken memory from the computer. It's ours. It's our own. So what we need to do is say delete PTR. So, but here's another thing. PTR has to be pointing at the right address. So if we did not have this minus equal and we did delete PTR,
we would be in trouble.
Yeah, we would be in trouble. Don't do that. You want to make sure that PTR is right.
Representing all students out there at this point. So why, when you just say int A or int X, you don't have to say delete X, but why are you suddenly having to delete I mean, I know you got new in there. But
Right. Well, because new allocates it on the fly. When we say something similar to, like you said, int A, this allocates it for us. It handles everything. Just think of it that way.
Right.
So when we start dealing with our own memory, actually starting to take control for ourselves, we need to make sure to give it back.
Let's take that a step further. So if you forget to do the delete,
right.
and you have allocated a lot of memory.
Right.
I mean, I know the warehouse thing works really well, but you've closed your program now.
Right.
What have you, in essence, done?
You've left the cardboard boxes out in the rain, and they're going to get soggy.
And this has a pretty common name that a lot of our
memory
beginners
leak.
may have heard of.
Memory leak.
This is a memory leak.
And for our example, if we don't have delete PTR here, it's likely that you'll never, ever, ever, ever find this error.
Not with the 2 gigs in this machine.
Especially not because of that. But, I mean, think about it. You only have, 10 bytes? No, I'm sorry, 20 bytes being allocated here, which is almost nothing.
Right.
So you could run this program again, and be losing 20 bytes each time, but that's that's big whoopee ding, you know.
Back in the 80s, it would have been a big deal.
Hey,
Back in the 80s, but now it's becoming more and more simple to just leave it go.
So if any of you out there are interested in time travel, keep this in mind.
Yes, exactly. So that kind of covers pretty much. Is there anything else we wanted to cover?
You know, I think we've probably fried a few brains out there.
I think so.
But that's okay.
We should probably call this good.
Okay, I think so. I mean, they can definitely watch it again and
again.
Referencing, dereferencing, how to set it up. You're pointing to an address. In the end, it's just variables.
Yep.
In the end, all this whole thing was just about variables. It's really about what are we storing in the variable.
That's right. We'll be
our
using
own
this.
data or an address that's pointing to some sort of data we may use. Or we could have an address that's pointing to another variable that's holding an address that's pointing to
another.
Oh, my brain hurts.
Oh, I'm sorry.
The pain.
Oh, yeah, wait a minute. I'm a student. I don't know what I just said. With that, that's going to conclude this lesson. So hope you guys got a lot out of it. Pointers are awesome, and trust me, very important, too. So that's going to wrap it up. Thanks a lot, everyone.